All right, so in 7.1, we just kind of looked at exponentials. And this unit is over exponentials and logs. They kind of work together. Okay, so we're going to look at what a logarithm is. And it's basically just another way to write exponents. So this over here is in logarithm or logarithmic form. And so if we see something that looks like this, we read it as log base b. There's normally a number there, so log base 5 or whatever number of a equals x. And we can write those as exponents. So we write them. This would be b to the x power equals a. So it kind of makes, we start at b and then x and then we go over to a. So it kind of makes like a backwards loop. B to the x power equals a. So if we want to write log base 3 of 9, if you type that in your calculator, and there's a way to do that, log base 3 of 9, it's going to equal 2. Well, we can also write that as an exponent. 3, so we start at 3 to the second power equals 9. And that is true. 3 squared equals 9. So number 2, if we want to write this as an exponential, 6 to the third power equals 216. So then number 3 would be 7 to the 0 power equals 1. We're not solving anything. We're just rewriting them in different forms. What would number 4 be? Yep, 2 to the 4th power equals 16. So we just follow this backwards loop. So number 5, 4 to the negative 2nd power equals 1 over 16.
Can I see the top again?
Then write down what you think number 6 is. It's 9 to the 3/2 power equals 27. Now we can also go from exponential to log form. And so you follow the same backwards loop. So it would be log. So you always start with log, and then the first number is 14. So log base 14 of 196 equals 2. Number 8, we would write log base 3 of 81 equals 4. Number 9, log base 12 of 12 equals 1. Then we would have log base 36 of 6 equals 1/2. Write down what you think 11 and 12 would be. Number 11, log base 2 of 1/8 equals -3. And number 12, log base 8 of 16 equals 4/3. Are there any questions? Okay. Let's look on to the second page. So there's something called a common log, and that's when the base is 10. So if the base is 10, you don't even have to write the base. You can just write log of x. Kind of like when you have an exponent of 1, you don't write the 1, you just assume it's there. Same thing for logs. If you don't see a base, you always assume that it's 10. So we may see some of that come up. So here I'm given the first part. I just don't know what it equals. So go through, I meant to do this. Go put equals x on all of those. And we're going to solve for x without using our calculator. So first off, we need to write these in exponential form for it to make more sense in our minds. So number 13, this would be 7 to the x power equals 49. We go our loop, 7 to the x to the 49. 7 to the x power equals 49. What does x equal? 2, because 7 squared is 49. Okay. So then number 14, we would write 3 to the x power equals 27. What is x?
The third.
3. So 3 to the third power is 27. Good. Number 15, I don't see a base there, but what is it? You don't see one, what do you assume it is? 10. So this would be 10 to the x power equals 100. So what is x? 2. 10 squared is 100. Try to get through 18. Question, do 16 through 18. All right, so number 16, you should get 0. Remember, anything to the 0 power is 1. So 12 to the 0 power is 1. All right, 17. 2 to the x is 64. Well, you may need to test it out your calculator, but it's 2 to the 6th power equals 64. And then 3 to the 5th power equals 243. So on number 18, x equals 5. Okay. Now number 19, we get 9 to the x power equals 1 over 81. So if you remember, to get fractions, that exponent has to be negative. So what is my x? It's negative 2. 9 squared is 81. But to make it 1 over 81, that would need to be a negative 2. Okay, and then 64 to the x power equals 4. Well, we're going smaller, so that power has to be a fraction. And before we do that one, let me explain fractions as exponents. If we have x to the 1/2 power, that's the same as the square root of x. If I have x to the 1/3 power, that's the cube root of x. Remember when we were doing square roots, I said you divide by 2. Cube roots divide by 3. That's where that comes in. X to the 1/4 power is the 4th root. Okay, and so on. So 4 is the cube root of 64. So that would be the same as having a power of 1/3.
It's like it could be it can either be. Oh, wait, never mind.
So any questions on those? All right, and then the last thing, we have something called the change of base formula. This is where we can turn something in and get it to where we have a base of 10. Now, the reason that might be useful is because most calculators have a regular log button, but they don't have it where you can make it log base 2. Now, these calculators do, and I'll show you how to do that in just a minute. But just, your phone calculator, maybe, if you turn it sideways, might have just a regular log, but not where you can change the base. So it's really easy to change it. If you have something with a different number base, but you want to make it a base of 10, that's the same as log of A divided by log of B. So number 21, we could just type in log of 64 divided by log of 16. And so in your calculators, that log button, this is the base 10. It's right by the 7. So log of 64 divided by log of 16. Make sure you close your parentheses. And you get 1.5. So 22, that would be log of 32 divided by log of 8. And that's 6 repeating. So you can just put that, or you can put 1.67. So number 23 would be log of 54 divided by log of 2. And if it's kind of an ugly decimal like that, you need to go to 4 decimal places. 5.7549. Because you're not going to know. If we try to solve these like we did up above, 2 to the what power is 54, you ain't going to know it's 5.7549. So it's not a whole number. But I will show you how to actually just type those in your calculator in these calculators. So if you go to math, and it's faster if you scroll up, but it's A, where it says log base, and then you can type those in, like number 24. I can just type it in. Those above 13 through 20, we could have just typed those in, but I wanted you to see where those numbers come from. Any questions?